Hi everyone, it's Math with AUB for the preparation of IBA first days, first lectures, 23 lecture series, first of 23, first of 23. Without wasting time, let's see and find out what sort of questions are present in quantitative or IBA direct test. Let's see and find out. Let me write again this question. Simplify 55 raised 5 divided by 5 raised 55. I have written the question very clearly for you. If something is cutting, it is not in the screen. I am writing for you one by one again. 55 raised 5 divided by 5 raised 55. 55 raised 5 divided by 5 raised 55. There is no need to worry about that. Just stuck to basic. Stuck to basic. 55 can be written as 5 times 11 overall raised power 5. I factored out, I factorized 55 as 5 times 11, 5 times 11 over 5 raised 55. By exponent rule, AB raised m, AB overall raised m can be written as A raised m times B raised m. AB raised m can be written as A raised m, B raised m. By virtue of this rule, I can distribute the power to 5 as was 11. So we can write 5 raised 5 times 11 raised 5 overall 5 raised 55. 5 raised 55. Okay. 5 raised 5, 5 raised 55. Bases are same, they are in division. We can subtract any power from anyone. Look, it is a smaller power, it's a greater power. So I subtract 5 from 55. So it can be written as 11 raised 5 divided by 5 raised 55 minus 5. They are in division, their bases are same. We can subtract either power, 55 from 5 or 5 from 55. In order to follow the options, no exponent is the negative. That's why I am subtracting 5 from 55. Smaller power from larger power, smaller power from larger power. Both have bases 5, both have bases 5, 5 raised 5, 5 raised 55. I am subtracting 5 from 55. So it is 11 raised 5 over 5 raised 50. 5 raised 50. It's my final answer. It's my final answer. So our option is C is the correct option. C is the correct option. Simplify 55 raised 5 over 5 raised 55. 5 is a prime number, cannot be factored. 55 can be factored, written as 5 times 11 raised 5. By virtue of this simple exponent rule, I can distribute the power to A as well as B. By virtue of same rule, 5 times 11 can be written as 5 raised 5, 11 raised 5. I have written. Look at these two, they have base 5. Their bases are equal, bases are same, bases are equal, they are independent. One can subtract either power from anyone. We can subtract 55 from 5 or 5 from 55. Have a look at the options. All exponents, all power in the options are positive. All the options are having positive power. That's why I am subtracting 5 from 55. Bases are same, they are independent. Subtract smaller power from the larger one. Smaller power from the larger one. So larger power is 55 minus 5. 55 minus 5. 55 minus 5, it will become 50. It will become 50. So our final answer is 11 raised 5 divided by 5 raised 50. Pass me the duster, please. Pass me the duster. Another one. Another one. A clean one. It might be somewhere here in the box. Check it out. Check, check. I'm trying my best. You can check. Okay. Okay. So we have done with question number 10. I am raising. Question number 9. Let me manage the question for you. We have been asked to find the largest integer m such that 2 raised m is a factor of 20 raised 8. Determine the largest possible of value of m such that 2 power m is a factor of 20 power 8. 2 power m is a factor of 20 power 8. Find the largest m. Thank you. Find the largest m. Find the largest m. Look, 20 raised 8. 20 raised 20 factors of 20. 2 times 2 times 5. Simple. Factors of 20, 2 times 2 times 5. Bases are same, they are in multiplication, add the powers. So 2 times 2 can be written as 2 square times 5 raised 8. 2 square times 5 raised 8. Now, by virtue of same exponent rule, ABC raised m, there is no middle symbol between them. I can distribute the power A raised m times B raised m times C raised m. So this one can be written as power having another power 2 raised 2 times 8 times 5 raised 8. So 2 8 the 16 times 5 raised 8. Now we have been asked to determine the largest value of m when 2 power m is factor of 20 raised 8. So in that case, if we compare 2 raised m with 2 raised 16, so our m is easily 16. So the largest possible value for m in that case is 16. 2 raised 16 is a factor of this one. 2 raised 16 is the factor of this one. For value of m, our correct option is 16. 16. We have been asked determine the largest value of m, largest integer value of m. When 2 raised m is a factor of 20 raised 8. 2 raised m is a factor of 20 raised 8. I have taken 20 raised 8. 20 can be factored out like a child. 2 times 2 times 5. 2 into 2 can be written as 2 square. There is no middle symbol, positive or negative. Positive or negative. By virtue of this exponent rule, ABC whole raised m can be written as A times m times B raised m times C raised m. I can distribute the power. By the same virtue, I have written 2 squared 2 times 8, 5 raised 8. 2 8 the 16. Then simply comparing with 2 power m, value of m is 16. Value of m is 16. We have done with another question. Question number 9. We have started in reverse fashion, in retrospective fashion from 10 to 1. Let's see and find out. Our question number next is question number 8. Let me write bigger one and clear one for you. If value of x is 1 over 9, if value of x is 1 over 9, then find the value of root x minus x square. Root x minus x square. What is value of x? 1 over 9. 1 over 9. Simple question. Let's see and find out. Root 1 over 9 minus 1 over 9 square. Root 1 over 9. Look at this. 1 is a perfect square. 1 is a perfect square. So root of 1 is 1. 9 is also a perfect square. Root of 9 is 3. By virtue of that simple fact, 9 can be written as 3 times 3. So it's 3. Or simply square root of 9 is 3. Minus negative square of 1. 1 times 1 is 1. 9 square. 9 times 9, it's R81. It's R81. Mostly the LCM, the fraction is actually seen of our students, especially having medical background. How to deal with that? Negotiate this one, it's really very easy. Just multiply the denominators. 3 times 81. For you, I am giving you a simple straightforward LCM method. 3 times 81, 3 times 81. Then multiply 81 in that direction, 3 in that direction. First, 81 in that direction. 81 in that direction. First, 1 times 81 is 81. Minus 1 times 3 is R3. So I have 81 minus 3 is our 78 over 3 times 81. Hang on, don't need to panic or multiply, apply a table of 3. 2 3 the 6, 1 carry, 2 6 the 80. So I have 26 over 81. 26 over 81. So our option in that case is 26 over 81. Again, have a look at the question. Let me brief you again. If the given part, it's given to us x is equal to 1 over 9, then evaluate root x minus x square. Root x minus x square. I have inserted the value of, I have switched the value of x equal to 1 over 9, root 1 over 9. Square root of 1 is 1, square root of 9 is 3. Cool. What about x square? X square. Square of 1 is 1, value of x is 1 over 9. Square of 1 times 1 is 1, 9 times 9 is 81. Then simply taking LCM, I'm taking LCM for you again to give you good view. Look at this. So value of x is 1 over 9 minus 1 over 9 square. Root of 1 is 1, root of 9 is 3, square of 1 is 1, square of 9 is 81. Taking LCM, simple LCM, just out of box LCM type. Whatever the denominators are, just multiply them. Whatever the denominators are, just multiply them. Then 81 times 1 times 81, it's 81. 1 times 3 is 3. Cool. 81 minus 3 is our 76. Sorry, 78 divided by 3 times 81. There is no need to multiply them. Just simplify first. 2 3 the 6, 2 times. 1 carry 80, 2 6 the 3 6 the 18. So I have 26 over 81. So our right option in that case is 26 over 81. Moving to question number 7. Moving to question number 7, we have what is question number 1? That's good one. If question number 7, let me write visible for you. If x is equal to 4, x is equal to 4, then find the value of minus 2 raised 2 times root x plus 2 plus 2. Just plug what is the value of given? Value of x is given, x is equal to 4. Let me write very clear for you. Minus 2 raised 2 times root x plus 2. So value of x is 2. Value of x is 4. Value of x is 4. Just write 4 instead of x. So I have minus 2 raised 2 times root 4 plus 2. 2 times root 4. What is square root of 4? 4 can be factored out. So root of 4 is 2 minus 2 raised 2 times 2, because root 4 is equal to 2. Root 4 is equal to 2 plus 2. Same. Minus 2 times 2, 2 raised 4 plus 2. It is not the case 2 4 8. Write 2 4 times. Write 2 4 times, because power belongs to only 2. 2 times 2 times 2, 4 times plus 2. 2 to the 4, 4 to the 8 to the 16. Negative 16 plus 2. Negative 16 plus 2. So our answer is minus 14 in that case. Minus 14 is the right option in that case. So option number A is the right option. That's question number for us. If x is equal to 4, then evaluate minus 2 raised root x plus 2. Are plugged in the value of x is equal to 4. 4 is a perfect square. So root of 4 is 2. One can easily factor it out. So root 4 is equal to negative 2 times, instead of root 4, 2. 2 to the 4. 2 raised 4. 2 raised 4 means 2 into 2 into 4 times. That's 16, negative 16. This power doesn't belong to minus. Minus is something additional. Minus 1 is the coefficient without power. Without power. This power doesn't belong to power. Minus doesn't belong to power. If that is the case, then we have converted this negative to positive, because it has even power. That is not the case. Negative sign is outside. Take care of this thing. Pass me the answer, please. Moving towards question number 6. Okay, let me take it myself. Question number 6. Question number 6. I have 25 plus 10 plus 10x plus x square root 2. divided by 2, divided by 2. Okay, we must have idea about perfect square. If we inspect the situation, 25 square plus 25 plus 10x plus x square in the root overall 2. Let's see and find out. 25, let me write for you. I can write 5 square instead of 25 plus twice 10 can be written as 5 times x. 10 can be written as 2 times 5 times x plus x square overall root 2. I can write here root 2. Now look at the situation. That's our a square plus 2 times ab plus b square. It is a perfect square quantity. It's a perfect square quantity. So I can write 5 plus x whole square overall divided by 2. The square root cancelled out because 5 plus x is a perfect square quantity. So I have 5 plus x. 2 is not a perfect square, right in the denominator. Right in the denominator. But look at the options. Look at the options. Option has also been switched over. You should have also a fair idea about that. There is a under root in case of denominator. Rationalize. Rationalize. Divide and multiply by under root 2. So under root 2 times 5 plus x under root 2 into under root 2 pair of 2. Pair of 2. So this one can be written as under root 2 times 5 plus x root 2. Under root 2 times 5 plus x overall 2. So our right option in that case is C. Or one can apply here Middleton breakup method as well. I have switched over to direct making formula perfect square. One can switch over to Middleton breakup. Let's see and find out how this can be done in another method by factoring out by applying trinomial type. I have 25 plus 10x plus x square overall 2. Okay, if I arrange this quantity x square in descending order, 10 times x plus 25 overall divided by 2. 5 the 25, 5 plus 5 10. Applying Middleton breakup or trinomial type, it can be written as x square plus 5x plus 5x plus 25 divided by 2. Taking the coefficient of the first and the last one. First write in descending order, take the coefficient of first and last one. 1 times the 25 is 25, factoring out 25 as 5 the 25, 5 plus 5 I have 10. Middleton breakup. Taking common, x common, 5 common, x common, I have x plus 5. Why? In that case, take common means apply, take a factor that is divisible by both 5, divisible by 5, 25 is also divisible by 5. In that case, x we have factored out, x is divisible by, x square is divisible by x as well as 5x is divisible by x. Factor means divide, taking common means divide. Taking common means divide. Taking common means divide. Look at this. X square plus 5x. I am taking x common. X plus 5. Again multiply x. It will become x square plus 5x. From 5x plus 25, I am taking 5 common. It will become x plus 5. Again multiply 5. It will become 5x plus 25. One can verify. Taking 5 common, I have x plus 5 overall root 2. Look at this. These two brackets are identical. Take them common. They must be. In case of Middleton breakup, x plus 5 is common. What remains? X and 5. Luckily, the other bracket is also identical to the first one. So it is a perfect square quantity. Or apply direct pair method. X plus 5 overall root 2. Overall root 2. In order to get rid of the third rational number from the denominator, divide and multiply by root 2. I have x plus 5 times root 2 overall under root 2 times under root 2. They can be written as 2 into 2 means 2 to the 4, square root of 4 is 2. So our right option in that case is that we have already taken is our C. Moving towards question number, I think 5. We have we have approached to our halfway. We have solved 5 questions. Now we are moving toward the next half. Question number 5. Question number 5. A good question to be checked at this exam. In this exam, or question of 5, 2 plus root 5, 2 minus root 5. Simply one can rationalize with the denominator, change the middle symbol, Change the middle symbol, divide and multiply. Change the middle symbol, divide and multiply. In order to save space, I'm starting from the first step. 2 minus 5. Look at this. A plus B, both brackets are identical. So I can write 2 plus root 5 whole square. What about this? A minus B, A plus B. That must be positive. Change the middle symbol, multiply as well as divide. Multiply as well as divide. Change the middle symbol, multiply as well as divide. So both brackets are identical. It's A plus B, A plus B, A plus B whole square. A minus B, A plus B. It is tantamount to A square minus B square. Difference of two square situation. Both brackets are identical, whole square. 2 plus root 5 whole square. 2 minus root 5, 2 plus root 5. Middle symbol is opposite. Difference of two square situation. Difference of two square. So value of A is 2, value of B is root 5. Applying method, whole square formula A square plus twice first times second plus square of second. A square twice, positive twice, first into second plus the square of second. What about the denominator? Square of 2 is 4, square and root cancel out, minus 5. Let me insert the values. First two brackets up put 2, the remaining two brackets root 5. Now look at this, A square plus 2AB plus B square. Square of 2 is 4, 2 to the 4 times root 5 plus square root cancel 5. 4 minus 5, take care of this thing, it's negative. 4 minus 5 minus 1. We can add 4 and 5 because they are independent numbers. 4, 5, 9, 4 root 5. Look at the impact of this minus in the denominator. Minus in the denominator. It is going to be multiplied with both, all the terms in the numerator. So it must be minus 9 minus 4 root 5. This minus is multiplied with each term in the numerator. This minus term is multiplied or divided. One can write in that fashion. 9 over minus 1 plus 4 root 5 over minus 1. It will become minus plus minus 4 root 5. This minus affect all the terms. This minus affect all the terms. Okay, cool. Whatever the situation is, if the square root is present in the denominator, then simply you have to rationalize. Okay, moving towards question number 4 and saving our time. So I have question number 4 as 2 raised 12 plus 2 raised 12 plus 2 raised 12 plus 2 raised 12. Okay, it's really very easy. Suppose it's Rx, it's Rxx. What you do in that case? X plus x plus x. You will write 4 times x. By virtue of same rule, we can add them 4 times 2 raised 12. We have done at our arithmetic algebra level, simple levels, x plus x plus x plus x, 4 times x. In the same token, we can write 2 raised 12 plus 2 raised 12 4 times 2 raised 12. Okay, cool. Now there's 2, there's 4. 4 can be converted to 2. I can write 4 as 2 square times 2 raised 12. 4 can be written as 2 square times 2 raised 12. Bases are same. They are multiplication at the powers. Write base 1 times 2 plus 12. Write base 1 time 2 plus 12. So 2 raised 14 is our answer in that case. 2 raised 14 is our answer in that case. We have started in reverse fashion. That's why now easy questions are coming. Question number 3. Simple exponent rule to be applied here. That's bracket x square times y overall raised 3 times z overall x y z overall raised 3. This power 3 belongs to x square and y only. This cube belongs to x square and y only, and we can cancel out here z direct. Okay, x 2 3 the 6 multiply power having another power 2 times 3 y raised cube overall xy overall raised cube. 2 3 the 6 y cube. So I can write x6 y cube overall xy raised cube. Look at this. Bases are same. They are individual subtract. Smaller power from the greater power. That's greater power. That's smaller. 6 minus 1. It will become x raised 5, 3 minus 1, it will become y square overall raised cube, by virtue of the same exponent rule that we have discussed several times in that very same video. Multiply power having another power, multiply the power. 5 times 3, y 2 times 3. So x raised 15, y raised 6 is the answer. X raised 15, y raised 6 is the answer in our case. So that's our right option in that case. What I have done, this cube belongs to x square and y. 2 3 the 6, I have written 2 3 the 6 as well as y cube. Z cancelled out. So it's okay, cool. Look at the x6 divided by x6 divided by x. Exponent are same. Subtract smaller power from the greater power. 6 is greater, 1 is smaller. 6 minus 1, it will become 5. There's 3, there's 1, y cube divided by y, it will become y square. So there's no middle symbol plus minus. I'm in a position to apply exponent rule to distribute the power 3 times 5, 15. So x power 15, 2 3 is 6, y is 16. So that's our option in that case. Moving towards question number second. Question number second is a good question. Question number 1 is the crown for a queen. For today's video, let's see and find out. Question number 2. If 2 raised 2x is equal to 16 raised x plus 2. Look at this. Such type of equations are known as exponential equation because our unknown lies in the part. Because our unknown lies in the part. That's why it's known as exponential equation. Exponent means power. From the noun exponent, exponential is the adjective. There's 2, there's 16. 16 can be converted to 2. I can write instead of 16, 2 raised 4. Instead of 16 can be written as 2 raised 4. Okay, 2 raised 2x same. Instead of 16 I can write 2 raised 4 overall raised x plus 2. Power having another power that we are discussing multiply. It will become 4x 4 to the 8. So I have 2 raised 2x is equal to 2 raised 4x 2 for the 8. Look at this. Instead of 16 I have written 2 power 4. Instead of 16 I have written 2 power 4. One can factorize 2 into 2 into 2 4 times. 4x 4 to the 8. Power having another power, multiply the powers. In that situation, a raised m raised n. So we can write a raised mn. Bases are equal, therefore powers are equal. 2x is equal to 4x plus 8. Okay, shift 4x here. 2x minus 4x is equal to 8. Positive 2x to negative 4x, it will become negative 2x. So by dividing 2 throughout, in order to arrive at the result for x, cancelled out. So x is equal to minus 4. X is equal to minus 4. X is equal to minus 4. What I have? Minus 2x is equal to 8. Divide by minus 2 to get to x. Cancelled out both. So x is equal to minus 4. So x is equal to minus 4 is the right option in that case. Okay. Finally, we have arrived at question number 1 and last for today's video. A good question, an elegant question. To me, from these 10 questions, it is very near and dear to me. Okay, if x minus y raised 1 over 3 is equal to x plus y raised minus 1 over 3, then which of the following must be true? Look at this one. X minus y raised 1 over 3 is equal to x plus y raised minus 1 over 3. How to turn this negative exponent into positive? How to convert this negative power to positive power? Let's see, x minus y 1 over 3. Make it reciprocal. Write its reciprocal, means 1 upon x plus y plus 1 over 3. That is the tip to convert negative power to positive. If it is in the denominator, write in numerator. If it is in numerator, write in denominator. Then exponent will turn to be positive. Mathematical rule. So from this, how to turn negative power to positive? Look at this. A raised minus m. So I can write 1 divided by a raised m. A raised minus m can be written 1 over 1 divided by a raised m. By same virtue, I have written 1 divided by x plus y is 1 over 3. Okay. Shift x plus y on the left hand side. From deviant to multiplication, I have x minus y raised 1 over 3 times x plus y raised 1 over 3. Look at this. Both have same exponent. Both have same exponent. We are in a position to write in that fashion. X plus y overall 1 over 3. x minus y raised 1 over 3, x plus y raised 1 over 3. Both have same exponent. I can write in that fashion. I can write in that fashion. Now x minus y, x plus y, it can be written as x square minus y square raised 1 over, raised 1 over, raised 1 over 3. Okay, cool. With what remains? Okay, let me manage again from here. So is this thing here that we have done? It's cool, good. 1 over 3 times x plus y raised 1 over 3. I have forgotten to write this right hand side is equal to 1. Now, like both have same parts, they are in multiplication. We can multiply the bases as normal. X minus y raised 1 over 3, x plus y raised 1 over 3. Both have same part, we can multiply the bases. X minus y times x plus y, it's x square minus y is equal to 1. In order to get rid of 1 upon 3, in order to get rid of 1 upon 3, taking cube both sides. Taking cube both sides. So I have x square minus y square 1 over 3 overall cube is equal to 1 cube. Taking cube 3 3 cancelled out. So I have x square minus y square. Cube of 1 is 1 times 1 times 1. So x square minus y square is equal to 1. X square minus y square is equal to 1. Look at this. This step to be swallowed gently. Look at this. X minus y raised 1 over 3 times x plus y raised 1 over 3. Look, write both brackets same. I can write instead of individual power as overall power. X minus y times x plus y raised 1 over 3. Instead of this, I can write this. Now you can understand a bit more further. In that case, x minus y, x plus y will become x square minus y square raised 1 over 3. Raised 1 over 3. Raised 1 over 3. So, to get rid of 1 over 3, taking cube. To get rid of 1 over 3, taking cube, or you can take the reciprocal of the power. There is 1 over 3 means 3 over 1. Taking the power 3 over 1 both sides. 3 over 1 means cube. 3 over 1 means cube. If there is such type of power is present, a raised b, then by taking, to get rid of a over b, take the power reciprocal. What is the reciprocal of AB? B over A. Then B cancelled out, A also cancelled out. To get rid of 1 over 3, to get rid of 1 over 3, take the power 3 over 1. 3 over 1 means cube. I have taken. So x square minus y square is equal to 1 is our right option in that case. Is right option in that case. This is our effort for the upcoming test of IB direct test. It's all by itself. Next.